Okay, shout out to Grace's peeps, who would be Gigi and Will, and Jessica and Natalie, and Rowan, and Julissa, and Grant Foreman, and anybody else. If I'm missing some, I'm really sorry about that. Okay, so anyway, what we're going to do is we're going to look at trigonometric form of complex numbers and de Moivre's theorem. And it is super cool. And I'm going to try to draw you in with interest right away. So my son, I told my son that the absolute value of -3 is 3. And Micah said, why, Daddy? And so what would you tell him? The distance from 0, right? Okay? All right? And so it brings up this idea of a number line. So for example, if you were to plot -3 on a number line, we know right where it goes, right? It goes right there. And if I ask you to plot the square root of 3, you know that it goes between what two integers? 1 and 2. Okay, that would be the square root of 3. But what about this? What if I asked you to plot 3i? And that's the point when you realize that this is just the real number line. That imaginary numbers do not fit on the real number line. And so therefore, when we're giving complex numbers, a plus bi, we have two parts. We have a real part, and we have what we call an imaginary part. And so instead of using a number line, we use a complex plane. We have a real number line, and then we have an imaginary number line. And together, they make up for us the complex plane. I'm going to make 5 tick marks for each one, because that's how I want to roll. So I'm going to start by graphing z sub 1, or 2 plus 4i. So what I do is I go over 2 units for the real part, and then I go up 4 units for the imaginary part. And I draw a segment that connects the dot from the origin, and that is the graph of 2 plus 4i. Over 2, up 4. I'll now graph z sub 2, -1 minus 5i. So that's back 1 and down 5. So that would be z sub 2, or -1 minus 5i. Yeah? Not too bad, huh? So what do you think we do if we do z sub 1 plus z sub 2? So z is a reference to a complex number. Z sub 1 plus z sub 2. What do you think we do? Take the two things and add them together. So we get 2 plus 4i plus -1 minus 5i. Well, only if we knew how to add complex numbers. Wait a minute. That was chapter 3.4 from first semester. So 2 plus -1 gives us 1, and 4i and -5i make -i. So we graph 1 minus I, or over 1 and down 1. And so that is our next value. It may seem kind of strange, but the black graph is actually a sum of the two red graphs. So it's one thing to look at it kind of algebraically. It's another thing to view it graphically and to see that. We'll get to that later. Okay, this next one says -z sub I. It should say -z sub 1. We're going to see if you can guess what you do to come up with -z sub 1. Anybody want to guess? Multiply by -1, so we get -2 minus 4i. Hey, what do you know? And if you would plot that, we would go back 2 and down 4, and we would get that. And what do you know? It's the same thing as our first graph of z sub 1. It's just in the opposite direction, isn't it? Kind of like if you plotted +2 and -2, they would be, the same plot. They would just be in the opposite direction, +2 and -2. Okay, same type of thing. Just we're in a plane. And then 1/2 z sub 1. How do you think you do 1/2 z sub 1? Yeah, multiply by a half, and I get 1 plus 2i. So I can go over 1 and up 2. And that's all I've got. Does it make sense that the green graph is exactly half of the red graph? Yeah, kind of neat, huh? Yeah. We all good with that? Did I hear a no? You don't have to enjoy it. You just have to. Do we understand it? Okay, all right, yay. We're together. We're together. So let us now define a modulus. And that looks strange, but it's not that big of a deal. The modulus is simply the absolute value of a complex number. Now, you guys told me earlier that the absolute value of a number is its distance from 0, correct? So think about our drawings up here. If we were to calculate the absolute value, we wouldn't be looking for the distance from 0, but the distance from the origin, since we have a plane, right? So the modulus is the distance from the origin. And we have a very basic way to calculate the absolute value of a complex number, or the absolute value of z. All we have to do is kind of just think about it. If we were to plot something right there, okay, it looks like we would go over a certain amount and then up a certain amount, right? So how would we calculate then that distance? Yeah. And all of a sudden now you see, oh, I get why we've done trigonometry and its introduction into what we call complex analysis. The absolute value of z is simply the square root of a squared plus b squared. So it is the use of the Pythagorean theorem. You will have that on a sheet of notes. But trust me. No, but if I asked it, I'm guessing you could come up with that one. All right. Now, find the modulus of z sub 1 and z sub 2. So we want to find the absolute value of z sub 1, or the absolute value of 2 plus 4i. We want to calculate that. Well, I'm using z sub 1 from the first one. So up here we said that z sub 1 was 2 plus 4i. So if I want to find the absolute value of that, I take the square root of what is a? 2. So I go 2 squared plus what is b? So I do 4 squared. You don't include the I. The B is what's in front of the I. The B is what's in front of the I. That's the first mistake that people make on the test. Because when they square it, you get a negative, right? You should always get a positive. So 2 squared, 4. 4 squared, 16. So I get square root of 20, or 2 roots of 5. So 2 roots of 5 is the modulus of z sub 1. Let's find the modulus of z sub 2. Absolute value of -1 minus 5i. Square root of what? 1 plus 25, and I get square root of 26. So if on the test, the very first problem, I ask you to graph a couple points, and I ask you to find the modulus, could you accomplish that? You've got your first points of the test. Good job. Would you like more points? Then you have to be able to do this next piece. And I feel that this is the most critical part of this unit. It's not the most difficult, but it's the most critical. We have 3 challenging parts to this unit. This is the first one. They get progressively more challenging. Here's the difference. If you can't get through the first one, there is 0 chance of being able to do the next 2. So we will end after example 3 today, and you really need to figure this out. We'll do a checkpoint on it right away tomorrow. Okay? Now, we are going to place these complex numbers in trigonometric form. And we wonder what that means. And I'm just going to show you for a second. If I said 1 minus I roots of 3, okay? And I was going to take that to the 100th power. That would be challenging, wouldn't it? To multiply that 100 times. Well, if we could teach you how to put it in trigonometric form first, I could do that problem in about 2 minutes. However, if I were to go home and multiply it out 100 times, it would definitely take me a few hours, and the chances of not making a mistake would be very unlikely. I would definitely make many mistakes along the way. Okay, so our goal is to be able to perform certain operations with complex numbers. It's going to be a lot easier if we place them in a different form. So we will start with this. A plus BI. So if I plot a complex number, z sub 1, it has a distance a along the real axis and has a distance b along the imaginary axis. Are we all okay with that drawing? Okay, so then let's move forward. Okay, first of all, you can even they thought it might help people on the ACT. Okay, so here we go. Yeah, it's the whole line. Okay. So what I'm going to do is I'm going to insert some parts to this. I'm going to call this theta, and I'm going to call this r. Do r and theta ring a bell? They should. And now I'm going to do something really crazy here, folks. I'm going to write down cosine. Can somebody tell me what cosine is equal to in this problem? Cosine of theta. Very good. A over r. How about sine of theta? So here's what I'm going to do. I'm going to take this A and this B, and I'm going to get rid of them. And I'm going to do that by solving for A. How do I solve for A? Multiply both sides by. So I get r cosine of theta is equal to A, and r sine of theta is equal to B. So what I can do now is I can take this and place it right there. And I can take this and place it right there. And when I do that, I get r cosine of theta plus r sine of theta times I. They both have what? R. So we're going to factor that out. And we're going to write r times cosine of theta plus I times sine of theta. So I just put the I in front instead of to the back. This is complex form. This is trigonometric form. So in order to go from here and here, we only need to find r and theta. Can somebody tell me how you would find r? Yeah, it's simply the modulus, isn't it? Isn't r the modulus? So r is the square root of a squared plus b squared. Good. And then for theta, I'm going to use a and b. Solve tangent of theta is equal to b over a. Morgan recognized that tangent of theta is equal to b divided by a. Is everybody okay with that? Tangent of theta is opposite divided by adjacent. We good? Well, that's how you're going to find theta. So in order to put it in this form, we need to find r and we need to find theta. This is how we find r. This is how we find theta. Are you ready for your first example? This can get you the first problem right on the test. Are you ready? Well, the first there's multiple layers. There's multiple layers. You gotta be able to do all of it. Okay? What? I did not know that. Ogres have layers. So do onions. Alright. Ogres are onions. Alright, here we go. We need to find r. We need to find theta. This you have to be able to accomplish for the test, or we will not have success. I start out with r. I need to take the square root of a squared plus b squared. What is a squared? 4. What's b squared? So I get square root of 8, which is 2 roots of 2. Awesome. Way to go. Now I'm going to find theta. I set up tangent of theta is equal to b divided by a. B divided by a. 2 divided by 2, which is 1. Sweet. So we have to solve for theta. Where is tangent positive? In the first and the third quadrants. So I'm going to inverse tangent of 1. And what do you get? 45 degrees. So I have two angles. What are they? 45 and 225. That's straight from our last test, correct? Yep. So here's the question. Only one of them's right. Which one is it? 45 because it's smaller and easier. You were correct in the answer. You were wrong in the y. Okay. It's because if you were to plot this point, if you were to plot 2 plus 2i, which quadrant would it be in? It would be in the first quadrant. Because you would go over 2 and up 2. Right? So therefore, 45 degrees. Now, we don't write it in degrees. We write it in radians. 45 is pi over 4. So, complex form of this number is, trigonometric form of this number is 2 roots of 2 times cosine of pi over 4 plus I sine of pi over 4. And that is your answer. Like your answer. Can I show you guys one thing to just kind of bring this full circle and make it really cool? I don't think so. I think it might enhance your understanding. I'm going for it. Watch. What's the cosine of pi over 4? Root of 2 over 2. Good. What's the sine of pi over 4? So, if we were to distribute this through, let's start by distributing the 2. If we were to distribute the 2 through, what would happen to the 2's in the denominator? It'll go away, right? So those cancel. So you're left with the root of 2 times the root of 2 plus I roots of 2. Okay? What's the root of 2 times the root of 2? 2. And what's the root of 2 times the root of 2? What did we get? What we started with. Yeah, see, we turn it in trigonometric form, then we turn it back to complex form. You don't have to do that, but that's how you check your answer. No, you're going to distribute it, so you're going to distribute this 2 right here. So you get 2 over 2, right? And then you're going to distribute it here. You get 2 over 2. I should have quit while I was ahead. Oh, well. Okay. All right, let's try the next 2. Here we go. You guys are doing well. I forgot the I on this one. It's 3I roots of 3. 3I roots of 3. I've got to find R. And I've got to find theta. I'm ready to go to work. How do I find R? What's A squared? 9. What's B squared? 9 times 3, which is 27. What's 9 plus 27? 36. And the square root of 36 is? All right. We're on a roll. Like, we're doing arithmetic. Good job. No, I'm just trying to keep things light. Tangent of theta is equal to B over A over, which is just negative root of 3, right? So I got to figure out, where is tangent negative? Oh my goodness, if I only knew where tangent was negative. Second and fourth, that's such good news. Well, am I talking about the second quadrant or the fourth quadrant? Olivia, why am I talking about the second quadrant? Yeah, if you graph this guy, it's in the second quadrant. You are intelligent. Way to go. No, for many times in your life, you are intelligent. We're not condescending to ourselves. We believe in ourselves. Okay, we inverse the root of 3 on the calculator. You get 60. And we know we're in the second quadrant. So therefore, what's my angle measurement? 120. Turn it into radians. 2 pi over 3. You guys are amazing. I can now write it in trigonometric form. 6 parentheses cosine of 2 pi over 3 plus I sine 2 pi over 3. Boom. Awesome. Like, you guys, you gotta, like, if your parents see you doing this stuff, they'll be so impressed. They'll think they need to, like, pull you out of Elberly and send you, like, a special school just for, like, gifted and talented. Like Hogwarts. They'll send you to Hogwarts. They're like, you must be a wizard. You're a wizard. Harry. All right, last one. What's different about this one? Yeah, there's no A, so I got 0 minus 2A. So I got to find R. I got to find theta. So I got the square root of what? Alex, what? No clue. Alex, pay attention, for crying out loud. 0 squared plus negative 2 squared. So, right, you got 4. I'm sorry, YouTube. Alex just walked in. Because, yeah, so I'm just making fun. So, no harm. All right, so R is 2, right? And then let's figure out theta. So I set up tangent of theta is equal to, no, negative 2 over 0. What's negative 2 over 0? Undefined. Where is tangent undefined? y-axis, 90 and 270. Are we talking about 90 or 270? 270, why? Yeah, if you were to plot it, it would be down here. So we're talking about 270, or 3 pi over 2. So therefore, we have 2 times parentheses cosine of 3 pi over 2 minus I, or plus I sine of 3 pi over 2. Now, here's the cool thing, folks. I knew this just by looking at the problem at the very beginning. You know how? Thank you for your confidence. I thought of the graph. How far is the point from the center? 2. What angle do I have? 270 or 3 pi over 2. Sometimes you just think about the graph and you're good to go. Get my point? You guys want an assignment, don't you? Well, thank you. I worked very hard at that one. Probably was not as good as the first one, but hey. Never outdo the original. I cannot implore upon you enough to not put off this assignment, because you are learning a new skill and you will not know how to do tomorrow's lesson or Wednesday's lesson unless you know how to do this. You have to know how to put things in trigonometric form or you will be lost. Raise your hand if you have other things to do tonight other than this. You will always have other things to do other than math. I cannot implore upon you enough. Make time to do it.